Sure. Let's get started. Okay, good evening everyone. In case you don't know who I am, my name is Billy Lamberti. I've been doing, art talks for the ASA club for about a semester, and then once in the fall of last year, of 2016. Yeah. So, without further ado, let's get right into what we're going to be talking about. So we're going to do a quick introduction of what we're going to discuss in this course, and then the other session themes that we're going to discuss throughout the semester. Then we'll get into the meat and the content of this 1 hour talk. We'll talk about data partitioning for two different types of objects, matrices and data frames. And then we'll talk about loading data into R, just some general tips, and then how to do it specifically for a CSV file. So, quick introduction about the setup for this course. It's a 1 hour talk, not from 12 to 1, 6 to 7. There's going to be the 3 session goal is to introduce R concepts and data cleaning. I assume that there's very little programming experience in things like C or Java, so it's very great. It's great if you don't. It's accessible if you don't know any programming languages, but if you already know programming languages or maybe a little rusty, it's still a great way to get back into things. And then if you have any questions at any point, please feel free to ask. I'm here to help and make this a valuable use of your time. So please ask questions if I'm unclear or where you would like me to discuss something a little bit further. So the session themes, this session is partitioning and loading data. Then we'll go into on session 2, some unique R object types that have some unique characteristics but are very important for you understanding how to use in something like ggplot. And then in day 3, we'll be using kind of messy data, transforming it into a clean way, and then creating some basic plots right from that. And so it kind of shows you, so the whole point is that we're learning how to manipulate data in the beginning, and then by the end of this, you're going to have a basic idea, okay, going through all that work of partitioning and cleaning data is important because I can do something and create something meaningful with it. And so that's kind of the general gist and goal for this semester. So let's get right into it. So matrices are one of the basics starting object types in R. If you don't remember what a matrix is basically an Excel spreadsheet where you have rows and columns and information in those rows and columns, and the matrix organizes it in a way that R can interpret and understand. To get access to subsets of a matrix, you have to use these brackets, and we'll go over some examples. And where the first part, if you're reading it, the left side of the comma is the rows. So your rows in an Excel spreadsheet, if you wanted the first to fifth observation or first to fifth row, you would just you would put some information on the left side of that comma. If you want things about the columns, you would put numbers and information on the right side of that column. Okay? That's the basic gist. And to really get a knack for this, let's just get right into it and do some examples. So let's first create some data. Very simple. We're going to create a vector first, and it's going to have the numbers 1, 2, 3, 4, and 6. So let's just refresh our memories to how to do that. It's x less than dash c, parentheses 1, 2, 3, 4, 6, close parentheses. And then let's just check to make sure that we saved it correctly, and we did. So this is just a vector or a single column or a single row in Excel of information. And it's saved in the object x. And to recall that information, we just type x, hit enter, and then it brings back that information for us. And so if we weren't sure what kind of object x was, there's some functions in R that will help us figure it out. So the first one is just is vector parentheses x. So this is saying, is this a vector or not? True. So if it's all caps, that's the response for logical information. And so this is telling us that yes, it is a vector. There's another object that we'll go over later called a data frame, and there's a function that checks that. And that's called is.data.frame parentheses x false. So this is saying, okay, this is not a data frame. So just basic things to understand what kind of data you're working with. Okay. So, but let's convert this to a matrix. So that comment right here where it says convert to a data frame, that's wrong. That should have been convert to a matrix. So let's create a new object x2 less than dash as matrix parentheses x, enter, and now it should be a matrix. So without even looking at it, I can just use the isMatrix function to check if x2 is a matrix. True. So we know it's a matrix. Now let's look at it. Okay, notice it's a little bit different from x. Remember what x looks like? Just a long row, essentially. x2, which is our new object, which is a matrix, organizes information a little bit differently. It looks a lot more similar to an Excel spreadsheet, right? And so you can already tell kind of where things belong and what the format is by looking at this. So if you look at x2, you have, for the first row, you have bracket 1 comma close bracket. So that says that's the first row of information. And then the second row of information is bracket 2 comma bracket. And then the first column is bracket comma 1. If there were more columns, you would see something like bracket comma 2 bracket. We'll see another example where it has multiple columns, but this is just to get a flavor for things. Yes, question?
Can you call an item just being like bracket 1 comma 1 bracket, and will that call that item?
Yes, we will see that. Yes, and yes, so like, for example, let's do a couple of examples now. So like for x2, if we wanted the x2 bracket 1 colon 3, anyone guess, without even typing it, what's going to happen?
It's an array.
Technically, yes, it's an array, but what is it going to produce? What am I going to see?
Rows 1 through 3.
Yes. So I just see 1, 2, 3. Okay? So if I wanted just observation 1 in column 1, that would be x2 bracket 1 comma 1. And that just gives me that one singular number. So notice there's only one column in x2. So when I did 1 colon 3, it presented as a vector because there was only one column. But if there was more, it would still showcase it as a matrix. But again, we'll see that as we move forward. Okay, so now let's do something a little bit different. Still working with matrices, but a different format. So let's create some character matrices. So the first one is just going to be y less than dash matrix, which is the function that creates a matrix, and row equals 2, comma, data equals c, paren, quote 1, quote, comma, quote 2, quote, comma, quote 3, quote, comma, quote 6, quote, paren, paren. And so then when we look at y, this is a 2 by 2 matrix because we said, okay, we want 2 rows and we have 4 data points, so it's going to immediately fill out the data in a way that makes it have 2 rows and however many columns that ends up being. So notice also how it filled in the information. It went down by column, right? So it started in 1, 1, then went to 2, 1, then went to 1, 2, then went to 2, 2. So when I say 1, 1, that means first row, first column. When I say 2, 1, that means second row, first column. Just making sure everyone's on the same page with that. Okay, so this is all character data. Remember, you can immediately tell that it's character data because it has quotation marks around it. Okay, now let's create a numeric matrix directly. And let's call it Q, so Q less than dash, matrix, paren, and row equals 2, comma, data equals C, paren, 100, comma, 99, paren, paren. And looking at Q, it's a 2 by 1 matrix. So now, what we're going to do is we're going to combine the character data and numeric data into a new matrix and see what happens. And to do that, we're going to use the function cbind, which combines objects by column. And so let's create a new object, new, less than dash, cbind, y, comma, q. Now looking at new, what happened? We have a 2 by 3 matrix. So again, it first combined the y object and then the q object in that order. Notice another thing. We started with q being numeric, so only like a numerical object. But now everything has quotes. So remember, with a numeric object, I can do things like take the sum. So if I take the sum of q, I get 199. If I try to take the sum of y, I can't do that because it's character information. Even though it's numbers, I saved it as character data, so I can't do anything with that. And so if I try to take the sum of new, I can't. Even if let's see what happens. Even if I were just to reselect my the column that was originally Q from new. So what was that? So new bracket comma 3, right? That's my old information. That's my Q information. What if I tried to take the sum of that? What would happen? Can't do that. It's now it's automatically converted to character data. So this poses a problem, right? If you were to have data that had not only numeric data like GDP, but also had information like state, Alabama, Alaska, Virginia, New Jersey. How are you going to work with that data? We'll answer that later. But for now, what I want everyone to do is this exercise. And so you're going to have a matrix. Come on. I want you to first create this matrix in R. Then I want you to create a new object that's partitioning only the third and fourth rows and the third column of this matrix. So you should have the numbers 76 and 22 in that new object. And that's it. But don't create a new object just by creating a vector, C, parentheses, 76, 22. That's not how I want you to do it. I want you to do it by partitioning or taking the appropriate parts of this matrix and then creating the object from that partitioning process. Okay? So you have 5 minutes, and I'll be around if you have any questions. Good, it's working. Okay, so first is creating the matrix, right? So I'm going to create an object X, matrix, parentheses, end row equals 4. I'm going to ignore end call, that's wrong. I don't know why that's there. You could put 4, but you don't have to. Data equals C, parentheses, 3, comma 7, comma 432, comma 0, comma 4, comma 100, comma 1, comma 14, comma 22, comma 678, comma 76, comma 22, paren. There's our data. And so then just creating a new object from rows 3 and 4 oh, no, it is right. There is 3 columns. It's been a long day, sorry. Yeah, and then I want the third column, it's gonna be 76 and 22, right? So what I'm gonna do is gonna do new less than dash, x bracket 3 colon 4 comma 3. New. 76 and 22. Now, there's other ways of doing this. What did I just do? I created an object called nams, short for names, and I wanted, I put 4 and 3. And then I said, okay, x bracket nams comma 3 bracket. And then I looked at that, and that's 22 and 76. These numbers were swapped around. You don't have to put this formal 3 colon 4. You can create an object and say, I want these things from my matrix. I want you to display them. Why is that helpful? Let's say you have a giant data set and a really bad computer. Right? You have like 1,000,000 by 1,000,000 data points and your computer just can't handle it. You could randomly select observations from your data and use those, right? But those random observations are not going to be in order from 1 to 100, right? They're going to be 5, 23, 1, etc., right? And so you can have a random numbers as an object, and then select those objects, and that's going to be your new information. Does that make sense? Mm-hmm. Okay. I don't also have, yes?
I was wondering, for like the first part up there, when you create the new matrix,
yeah.
If you set like n rows, let's say 2, what would happen? Would it just take only the first 2 rows and ignore the rest of it?
No, it would keep all your information, but then it would say, okay, everything is now 2 rows, and just fill as many columns as I can, essentially. So you're gonna have, you can't really see that. It's gonna be a 2 by 6 matrix. Okay. Now, is new still there? Yes, okay. So new, I'm just going to reassign new as a matrix. So new as matrix. So see, it took the old object new, converted it to a matrix, and I called it the same thing. So I basically saved over my old new object. Now I have it as a matrix. So if I wanted to not use numbers, but maybe display them with names, I could do that using the call names function on new, less than dash, and then whatever I want to call it. So in this case, I'm going to call it third. So I'm going to have I'm going to create my list of names, and that's going to be C parentheses quote third quote paren. Now if I look at new, you see that it went from bracket comma 1 to third. And so I can do the same thing with the rows using the row names function and do third comma quote fourth. Now if I look at new, it's third, fourth. Okay? So just different ways of manipulating matrices. Any questions? Yes?
If you were trying to skip over like name the second and the fourth one, how would you write your code that way?
So say that again.
Okay, say if you have the full matrix, the original
Yes.
X, I think that we called it, and you wanted to name row 2 and row 4, would you do, how would you type that up?
I would basically do what I was doing. I would create noms
Okay. Oh, you would name
less
the
than
object.
dash
Got it.
C second 4,
Okay,
and then put that in, and that would get it.
thank you.
Yep. Okay. So, data frames. Remember that problem I posed earlier where you have numeric information and character information? Data frames is the solution. Data frames can handle both numeric and character data in the same object, and it doesn't lose any information. However, because it's more flexible, it's now more ambiguous. And we'll see why it's more ambiguous when we look at some examples. But data frames are extremely important in a lot of different packages, such as ggplot2, which is a very popular visualization package software. Okay? So, we're going to just make sure we have the right object renamed. I'm not going to go over is it a vector, is it a data frame again. But I'm just going to make sure we have the same data as we did before. So x less than dash c paren 1, 2, 3, 4, 6. All right, and we can check that it's a vector. True. We saw this. Okay. So now x2, we're going to call this a data frame, and we're going to see what it looks like. So x2 less than dash as data frame parentheses x. Now if we look at x2, looks a little bit different than when it was a matrix, right? So when it was a matrix, it had bracket 5 comma bracket. So this is just 5 though. So it's just presented differently. So that's another hint that what kind of object it is without actually knowing, just by looking at the object and seeing how it's displayed. But we can formally check doing is data frame, and it is. Okay? So this is numeric, a numeric data frame. This is how it looks. Notice that the column is not a number, it is the object name. That's an important feature to be aware of. And so now let's create some data frames with character information. See how that looks, and then combine it with some numeric information and see what happens. This is all going to look very familiar. We're going to start off. Well, let's just, oh no, I don't have that object anymore. So we're going to recreate, this is from the previous example, we're going to recreate some objects that we had. Let's see if I still have Y, and I still have Q. Great, don't have to do those lines. So let's create a new object, new cbind y comma q. Right, and if we look at Q, remember it's all character matrix. Okay. Now, what happens if I first convert them to data frames before combining them? What happens? y2 less than dash as data frame paren y. y2 looks like this. Okay? So I still have my numbers for rows, and then my columns, though, are v1 and v2. So if I have a matrix, it's not going to be the object name, it's just going to be v1, v2. And notice there's no quotes. Okay, we'll talk more about that in a second. Let's create Q2, so Q2 less than dash as data frame. Q, and then looking at Q2. Okay. So very similar. We have 1, 2, no quotes. It didn't have quotes originally. Q. Right? This is Q, this is Q2, data frame, matrix. And then, but same setup here. Okay. So now, if I were just to create new 2, less than dash, cbind, y2, q2, what would happen? So here's new 2. New has all quotes and is a matrix. New 2 doesn't have quotes and is a data frame. And there's 2 columns with v1 in the name. So remember I couldn't, so here's y. I can't take the sum of y, right, because it's character. So I'm guessing, right, that I can't take the sum of y2, which is correct, because you have character information. That's the same as new 2, or new. And remember when I took the sum of new and I did the third column, I couldn't take the sum? I can with data frames though. So again, data frames, very flexible, but not super clear, right? So again, just make sure, it's really important to recognize different objects have different flavors to them and can have different features. So there's another neat thing about data frames is that, let's say I want to first create all unique columns, column names, and then I'm going to grab some information in a different way. So I'm going to take the sum in a different way than I presented before, where here I did bracket comma 3. What I want to do is say, take the sum of column 3, whatever that name is, let's call it V3. I want to take the sum of that. I don't have to know that it's the third column, I just have to know the name of that column. I want to be able to do that and just take the sum. So let's figure this, let's work out how to do this. So first I have to rename the columns, right? So I'm going to do column names of new 2, less than dash, and then what the column names are. V1, comma, quote, V2, quote, comma, quote, V3, quote. So now if I look at new 2, I have V1, V2, V3. And so then if I just want to look at the information with a specific column name, I can do that doing new to $, and then the name, V3. That's saying I want that information. And then I can just do normal operations like I did before. Right? I can just take that information and do operations on it. Why is this helpful? Because let's say I have a big data frame with 100 rows, or I don't know, 1 million rows by 100 columns. I don't know the exact location of every single variable, but I know if I wanted to take the average GDP for every state, I could do that very quickly by doing mean, and then my data frame, and then the name of that variable, so it would be GDP or whatever. In this case, it's just going to be V3. I can get the mean. I don't have to know that it's the third column out of 1 million. I can just grab it. So it does ease some complexities in dealing with data. Being able to just retrieve a name that I know it's called and do operations on it. Okay. So we talked a lot about manipulating some objects, but we never talked about how to get data into our session. R has the ability to work with a lot of different file types like CSV, text files, Stata files, SAS files, SPSS files. The list goes on and on. There's a problem. All those files are created in different ways. So they all need to be exported in a special, unique way. That's the complexity, but the solution is that everyone's basically done that for us. So we don't have to do a lot of work. We just have to know who created it, what package it's in, extract that, and install that package, and then use that function that loads that information for us. There is a really good website that has a lot of commonly used packages that's included in the handout, and this is just some stuff. And so it tells you this is the library, this is the package that has this package to extract this information, for Excel files. This is the one for SPSS. This is the one for SAS, etc. It has a whole bunch. They're all the same process though. They have some function that reads in a file and you have it. So we're just going to do something very simple. We're going to do CSVs. Because CSVs are everywhere. It's where it's a lot of information saved that way. A lot of programs can convert a Stata file, if you have Stata, and convert it to a CSV. Or if you have Excel and you have an Excel file, Excel can convert it to a CSV. So even if you don't have the ability to or know exactly what package extracts an Excel file, you can just go to Excel, convert your file to a CSV, and then load it into R, and you can go run it. So, there we go. We're just going to do CSVs because that's a great starting point, and it doesn't require package installation. So we're just going to create a simple object, x less than dash, c, paren, negative 0.6, negative 2.3, negative 0.4, paren. There's our object. And so now, what I'm going to do is save this object into my directory, my working directory, where all the information I can see can be pulled from. To see what files I have, I just do dir paren, and that tells me if I have any files there. Can't remember off the top of my head, but there is a function that can tell you exactly what your location is on your computer and what the extension is. So if you're in documents, school, etc., there's a function that tells you exactly where you're located in base R. And in RStudio, you can just click on files and drag it into your session. It'll do a lot of these things for you. But to now save this object X, I can do the function write.csv, paren the object I want to save, or objects, so I can do multiple objects if I wanted in some instances. Write CSV, quote, my data dot CSV paren. So this is just the object I want, and then the file extension. So now if I look at my directory, I see that I have this thing called my data CSV. And so if I look into my directory that I'm now in, there's this my data CSV. And just to really drive this point home, I'm going to delete it, then do write my CSV again. There it is. Okay, remember the list function? This tells us all the objects that we have in our workspace for R. So I can now recall noms if I wanted. But to really drive this point home that I'm going to reload this information from my CSV correctly, I'm going to delete everything. So I'm going to do the remove list equals a list, and now there's nothing there. So if I try to recall noms, there's nothing there. And so now, when I go to this slide here, I'm going to read this information in using the read table function. So I'm going to create a new object y less than dash read table paren my data dot CSV quote comma header equals true. So this tells me that I do have a header in my CSV. Speaking of which, we should probably look at our CSV before we load it in to make sure we know what's happening. So when I saved it saved it a slightly different way than what my object looked. I have 1A is completely blank, 2A is a 1, 3A is a 2, etc., right? So this is the row, that's the object, and that's the information it saved. So you should check out how your data is saved before you load it back into R so you can put in the correct information. So now that we know that we have to have a header, right? Because this is saying, okay, the first row in our CSV is a header. It's not information that we want to analyze, it's names of something, right? So header equals true, and then separated by a comma. You have to tell it what it's separated by, because there's different ways of saving CSVs. The acronym is comma separated CSV. I don't remember V.
I think it's
but
value.
Value, thank you. Yeah, so it's separated by columns. There's other files that are just separated by tabs or spaces, etc., right? And so you need to tell it how it's separated. To check that, if you open this with a text editor, come on. You can see this is what the raw information looks like. Each cell is separated by a comma. Okay? So you need to be sure of how your data is stored. And so now, when we read this information in, how does it look? Looks a little bit different than how we originally had it. But now the information's there. So if we wanted to convert X or Y to be like X, how we originally had it, we'd have to finagle a little bit. So if we were to use the function as unname, so to get rid of the names of the rows, and then convert it to a matrix, it might look like something we're looking for. So let's just do this step by step. So unname Y, 2 N's. Okay, so it gets rid of the column names. And then it looks like there's more information than I need, right? So like, let's look at the dimension of Y. It's a 3 by 2, not a 1, not a 3 by 1. So that means that there's 2 columns. So if I wanted to get rid of the first column, I would, there's a quick and easy way to do that. I could do Y2, let's create this new object, Y2, Y, bracket, comma, -1. So when I put minuses in my brackets, that says deleted. Right? So again, to kind of drive this point home, Y, bracket, -1, comma, bracket, says get rid of the first row. So sometimes when you import data, it might come with things that you don't need, like we do here. And so you can quickly delete that information by just doing -1 in the appropriate spot when you create a new object. Okay? So, we only have 10 minutes, but I have another quick exercise. I want you to install the package ggplot2 if you don't have it, and that you do on line 2. And then I want you to load the package ggplot2. You don't have to really know exactly what's happening, but basically it's going to have an option from what server do you want to download it from. Pick one in the United States, and that's pretty close to us, so I think a close one is PA. or New York. Those are pretty close. And then a lot of these packages have data sets built into them. And so to load a data set, you use the function data, and then what the data is called. And so then I want you to extract that information, the data economics, using the data function, which is on line 4. And then on line 5, just convert it to a data frame. And then on line 8, I'm getting the dates as an object from my data frame. And then I'm getting the month on line 9. Okay? So I'm giving you this information, use it to then add a month column, bless you, to the data frame. Then I want you to save your data frame as a CSV and then try and reload it back into your session. So delete everything in your workspace and then reload it back in. And then if you have extra time, save it as a stata file, which is a DTA file, and see if you can figure out how to do that. The solution to how to figure that out is on the website that I provided earlier. But that's just a bonus. See if you can just do the first part, saving it as a CSV. You have until, let's say, 7 minutes, so then we have enough time to go over it. Okay? Okay. We only have a minute. So let's group back and we'll go over my solution. There's different ways of doing this, so that's why I say my solution. There's not necessarily a right way. This is just the way I did it. So, assuming that you did everything correctly on the first slide that I provided, I'm going to create this new month in one line on my data frame just by using month, $, and then the name that I want to give it, and then the object that I saved it in. So just to give you an idea of what my data frame looks like before, it has date, PCE, pop, etc. Right? It doesn't have a column named month. So I'm going to do my df $, month, <dash, MON. So now if I look at my data frame, I see that I have month all the way over there. So again, data frames are nice because they're flexible. I can create a new column and say it has this name and it's this information, and do it very quickly. So now all I have is my DF or my CSV there, my data CSV. And so I'm going to write this CSV, my df, comma, quote, my data.csv, that's what I'm going to call it. I just saved it. That's the information I have in my workspace. This is the information I have in the current folder that I'm in. And so I'm done. I did what I was supposed to do. Let's look at it. There's the information as a CSV. Okay? So if I wanted to also do it as a data file, I could just do install packages foreign, but I think I already have it, so I'm just going to go right to loading that library up, or that package up. And then I'm going to do write.dta as data frame, my df, just to kind of, you don't have to do this because it's already a data frame, but if it wasn't a data frame, you could do it right then and there. So as data frame, comma, parentheses, my data.dta, quote, and now there it is, my DTA. And so then if I look at new, there's nothing there, it's just some function. But if I want to call read in this data file, I could do new less than dash, read DTA, parentheses, quote, my data dot DTA, end quote, parentheses. And I look at new, it's now there. So there's lots of different ways to save information and load it and to manipulate it. This is just 2 different files that we looked at. There's lots of different ones like Excel and SAS files, etc. There's too many to go over, but they're all basically the same thing. You basically, if it's a foreign file type, you load you install a package, load the package, save that file type using write, and then usually it's the file type name, and then you upload it using read DTA, read XSLS, whatever Excel's file its name is. It's pretty straightforward once you just know where it is located in the package, or what package has it. Any questions? No? Try and enjoy this warm weather.